Thank you everyone for joining the November VMware TAM customer webinar, where today we're joined by Principal Data Engineer Alastair Turner and Principal Solution Engineer Robbie Jerrom to be discussing VMware data solutions. Please do make use of the Q&A feature to ask any questions. We will be stopping throughout the webinar to answer any questions. If your question doesn't get addressed today, please do reach out to your TAM and ask them to follow up. Before we get into today's content, we do just have a couple of quick announcements. So our next TAM customer webinar will be on December 8th. We'll be covering the newly released and much anticipated vSphere 8. At the end of today's session, you will be prompted to fill out a simple survey related to the value you received from this session, and also to provide any topic suggestions for future sessions. So we would really appreciate if you could spare a couple of minutes to complete this. And lastly, this webinar is being recorded and your TAM will be able to make the recording link available to you in the coming days. After a few months, you'll also be able to access the recording on the publicly available VMware TAM Services YouTube channel, which you can access from the QR code on the screen. So that brings us to today's topic, building a data platform with VMware. So I'll now hand over to our speakers, Alastair and Robbie. Thank you.
Great, thank you very much, Amy. So good afternoon, good morning, everyone. My name is Alastair Turner. I am VMware's friendly London database nerd. I am a member of the Office of CTO's global field program as a principal data engineer. So I spend a lot of my time working with customers to understand what they are doing to get value out of their data and how we can help that along. I'm joined today by Robbie, who will be introducing himself when we do the first handover of the content. So we're just very quickly going to run through what we want from machine learning, why it's a hassle, and what it is that we can do to help with that. So starting with what machine learning is, branch of artificial intelligence and ComSci, which focuses on algorithms. There are bits of it which more closely seek to emulate how humans learn. We start getting into the deep learning, building neural nets, and those sorts of areas. And there are some adjacent bits which are about statistical approaches, about some of the more traditional approaches to making numbers understood and to being able to make decisions on the back of numbers that are based on matrix algebra and some more mechanical kind of approaches. And we're going to talk about a little bit of both of them. Obviously, the deep learning is a big deal at the moment. It's something which a lot of us are hearing demand for. So part of the reason that we felt it was worth having this discussion is that AI is out there and it's shaping everything. So credit card fraud is an area where a lot of machine learning has been used for a very long time. And close to the end of the presentation, there's actually an interesting example of how we work with one of the big issues around that. We're seeing systems that are getting better at doing voice. This is very, very firmly in the sort of the deep learning networks world. The voices that every now and again can understand what we're saying instead of a human contact center operator. Meetings transcriptions, I think we all use them these days on Zoom, Teams, and the like. But particularly in the area of vision, there have been some very interesting recent developments, among them from our partner NVIDIA, who Robbie's going to be talking about a bit more later, around things like medical imaging and industrial inspection, to use the data coming in from cameras to make decisions and get to conclusions faster than people may be able to. So machine learning is also really not just one thing. It's a collection of processes, a collection of pipelines, a collection of journeys that various things go on. There's a journey that the data takes around, sort of being acquired, being cleaned up, being prepared for use. The process of exploring that data, then sort of by the experts in ML, has its own set of tools, which then produces some outputs that need to be orchestrated. The journey of the model, the life cycle of the model, and then there is also not really visible on this picture what happens to the requests that come into the model to be scored for a decision, whatever it is that the model is expected to do for you when it's deployed in the real world. So starting with that data journey, and this is where we meet the first persona who may be coming to you in your roles in the virtualization estate or in the infrastructure estate to look for computing or network or storage capacity, and that is the data owner. So the data engineer. So the data engineers, I suppose in short summary, are tasked with getting the data ready for use. And that use could be by the data scientists, who we're going to talk about next. It could also be by some of the more traditional uses of data, like BI reporting. That's not as sexy a topic anymore, but it's still very important. We still need to be able to just get basic descriptive numbers about the business to understand what we're doing to make effective human decisions, even if we aren't then passing that data on to a machine to make some faster or some more personalized decisions. And the process here is firstly one of collecting data. There's a lot of connectivity here, a lot of linking up with existing systems. Some of it is API based. A lot of the SaaS services offer APIs for being able to pull records, either in bulk or one at a time. There's obviously a set of authentication stuff to be managed around there. Another very common source is the underlying databases of in-house applications. The process of change data capture, of getting those changes reported as they happen, rather than having to do batch extracts, is becoming, or has become over the last 8 to 10 years, a lot more common as the data volumes have grown, because the batch operations were just running out of windows. They were running out of time windows. They were running out of bandwidth to be able to move all that data in bulk. And also because the expectations of when the data will be available have been shrinking. The time from an event happening in one of these source applications and being visible in the BI reports, everyone's expectations have moved from that being acceptable at one day to having to be within hours or possibly even minutes. So having been collected, we have a bunch of data in the same shape it was in its source environment. And that's generally where we see the discussion of a data lake, data in whatever form it happened to arrive in. This isn't necessarily an unstructured environment. It's not necessarily opaque. This is often a data warehouse of sorts, a big database of sorts, just not cleaned up yet. And then the first thing that's really important about getting the data ready for use in a learning environment, or even for any of these other human decision processes, is making sure that you can add these things up, that you can average them, in the same way. So there's a lot of cleaning, a lot of transformation to ensure that the labels are the same, so that you can join them up, that you're using the same baselines, that you've got your decimal points in the same places, that you aren't using pounds in one place and pence in another. And that then gets us to this clean data collection, which we can use either for the more traditional human decisions or for supplying to the data scientists. Now, it's not at this point quite finished yet for feeding into machine learning. It's not ready for a machine, because there are a bunch of things that we see in data that are not right for applying to these machine learning processes to, because they need to be packed slightly differently for the purpose. Now, who exactly is responsible for feature engineering can be a little trickier. This may be the data scientist, and in fact, for the initial passes, it probably is. But this is one of the pieces of work which needs to be taken out of that experimental environment and taken back into the production world to ensure that this data is prepared in a consistent way again and again. One of the obvious examples around feature engineering is the categorical variable problem. If you want to do some of the more sort of conventional regressional clustering kind of analysis on this data, there needs to be essentially a field per option in the data sets. That's one of the things that we do in the feature engineering. Also, there are some things that people might be tempted to turn into numbers, but that the machine learning processes may then misbehave with if they're numbers. Days of the week, numbers 1 through 7, they aren't actually numbers that form part of a calculation. They can't be treated that way. Whereas some interesting things about the days might be, how far is it from a weekend on either side? That might be an interesting way to look at it for how the day affects certain machine learning outcomes. So now our data has gone through the process of being collected, cleaned up, standardized, and we've got some features. We can start trying to explore it. So the data scientists, the analysts, whatever you want to call them in an environment, data scientist is the most common title we see, are responsible for building the models, checking the validity, the usefulness of the models. So generally very strong background in one of the statistical scientific disciplines, but not really software developers. So a lot of the practices that we have been learning around software engineering for the last 20 years or something are not instinctive for these people. We need to try to bring some of that thinking into that world so that the output of this process can be used in production the same way that any of the code we write is used in production. And the process that these analysts go through is firstly exploratory, just digging around in the data a bit. And then we actually start to see our first ML models. So the deep learning area, which is so interesting at the moment, PyTorch, Keras, big frameworks there for building neural networks. And then for some of the more traditional things, scikit-learn is one of the names you'll hear in the Python world for doing all of that work. Now, once the data scientist has found something useful, has found something that they believe is safe, and this is also a big piece of where the importance of the statistical and scientific background comes in. Not just that here is something interesting, but here is something that's interesting in a meaningful way. The test data sets behave. Constructing a good test data set is a very important thing for the data scientists to do. Now, the stuff needs to become a production app of some sort. And this is where we see the emerging roles of the ML operations and the ML operations engineers. So building the infrastructure that these models are going to run on in production, and ensuring that they are reliable pieces of whatever applications they get integrated into. So ensuring their availability and their uptime, monitoring them from a performance and capacity point of view, but also monitoring them from a quality point of view. Models which get to modify some of their own input data can drift away over time. So the work that the data scientists did initially around validating them needs to be done on an ongoing basis to ensure that they remain useful, they remain accurate. So if we just look at that process again, following through from the data scientists to the machine learning ops folks, the exploration happens in the notebook and workbench kind of environments. Jupyter's a big name there, but it's by no means the only one. And that gets a first version out, which then needs to be stabilized. There are various ways of turning that exploratory stuff into more rigorous code, which Robbie will talk a bit about shortly. And then all the work for feeding them the data, etc., needs to be formalized as well. Then take them out into the real world, deploy them. So this is really when they become available to either the customer or whatever internal process is using them to be used. So they're served, and the feedback cycle needs to run back again if things are going wrong in the serving environment. If drift is happening too quickly, something else needs to be done, either at the model construction phase or at the build phase. Right, so I will stop there to hand over to Robbie.
Cool, thank you, Alastair. Just share my screen. Okay, quick check. Can you see the slides okay?
Yep, coming through fine, thanks.
Fantastic. So thank you, Alastair. I'm Robbie. I'm also part of the Office of the CTO. I focus very much on the machine learning platforms and the NVIDIA solutions. So Alastair's explained the personas of the data science world and how you get the data into a position where you can have some value from it and move it into production. But when you start looking at the platform, how do we actually make that useful from an IT perspective? Because there is tremendous struggle between the data science community or the AI practitioners or that side of the house that need to be able to experiment quickly, understand the maths, understand the complicated part of the data science piece, and how you move that into production, how you do that at scale, how you monitor it, how you deliver it, how you look after the traditional infrastructure that supports it, and how you secure it. And that's the real struggle, is how you cross that wall between innovation around data science and machine learning and making it production grade. And that's where a lot of projects fall down, is jumping that bridge to taking that model into something that has business value and is secure, resilient, and scales. And that's very much VMware's wheelhouse. That's what we're really good at, delivering production solutions that deliver on all those things. And the first step to delivering that is a lot of consistency. So a lot of the tools that Alastair's been referring to, there's lots of different variations. There's lots of different ways of creating that model and doing that data science work. And it normally is a case of a data science asking for a virtual machine, putting all their favorite tools into it, and then that's what they work on for the next 3 years, and they update it when they feel like it. So delivering a consistent platform with consistent tooling and that management and that accelerated infrastructure, and making it easy for the data scientists to just do their job, which is experimenting on the data and building those models without having to worrying about all those versions of software, all of that tooling and all of that infrastructure stuff, is what we're focusing on. So delivering that integrated solution so the data science folk can just get on with what they're doing, which is delivering the models that drive business value. And that's what we've been working with NVIDIA, who are almost the undisputed powerhouse when it comes to the GPU learning, to deliver a unified solution. And this piece comes in a number of elements. I'm going to drill into these in a little more detail. Firstly, of course, we have the infrastructure, you have the hardware, you have the NVIDIA accelerated compute, the GPUs in the physical servers that give you the ability to build those machine learning models, to do that complicated mathematics at a huge scale at real velocity. But sitting alongside that is obviously the VMware infrastructure layer that gives us the platform, gives us the Kubernetes platforms and the VMs to access that hardware in an abstracted manner. But then the next level above that is the software stack, the ability to do the text recognition, the conversational AI, understanding images, without your data scientists having to start from scratch. And the NVIDIA AI Enterprise solution includes all of those components, as well as obviously the GPUs and the hardware pieces. So delivering that end-to-end stack of access to GPU compute when you need it in a flexible way on the virtual platform through VMs or Kubernetes, and having that library of pre-built, pre-optimized container images that let the data scientists already accelerate that work that they're doing. They don't have to train a machine learning model to recognize a dog from a JPEG image from scratch. NVIDIA can provide a container image which is already 95% accurate at recognizing animals and identifying dogs from cats or breeds of dogs, for example. You just need to tune it for your use case and do that last step and put it into production. So providing those pre-built models is a large amount of the value that we've got around this solution. And equally, those models are updated and republished through the library, NGC library, over time as well. So as data science moves forward, as the ML models become more efficient, and that 95% moves to 98%, using these pre-built models as part of your basis for your ML application is you get that boost out of the box. And the same with the frameworks. NVIDIA recently updated one of their ML frameworks, and you got I think it was like a 30% speed increase just from code optimizations. So there's a real value in that end-to-end engineered solution across the board. But the next element that comes up with conversations around machine learning platforms is obviously speed. How long does it take to train the model? How long does it take to get it into production? And traditionally, that's always been a pushback from the data science community, where they've got a bare metal server or they've got a highly optimized environment already. And we've been working on that. We've been working really hard with NVIDIA to deliver near bare metal speed for GPU accelerated, machine learning accelerated workloads on vSphere. To the point where we're almost at the point where it's not indistinguishable, but we also deliver all of the functionality that you expect with a vSphere platform. So the ability to do resource management, the ability to do vMotion, DRS for initial placement. So all of the things that we've taken for granted that didn't exist in the bare metal world for machine learning now gives you that stable, flexible platform, where if you have to update a server and a machine learning workload has been running for 3 hours or 3 days, you can move it without interrupting the workload. You can make efficient use of the platform with DRS placement. You can make sure those ML workloads are running in the right place on the right hardware and getting the most value for money. And one of the metrics that was shared with me at VM Explore Europe with from a customer that's doing a lot of data science work was their bare metal platform was only utilizing 6% of GPU time. That's a tremendous waste. So they're moving over to a virtual platform so they can get more efficiency above that 6%, which is a terrible number. So delivering that flexible platform and getting the most out of the expensive GPUs the data scientists need is a key value add here. As is fully integrating the platform. I mean, we've talked about, you know, giving access to hardware, giving access to container images, but by fully automating that with Tanzu, we can deliver a fully automated service end to end. So you can deploy a TKG cluster onto your vSphere environment or VCF environment, deploy the access to the NVAI Enterprise Container Registry, gives data scientists access to those accelerated pre-built models and optimized frameworks for the GPU, and they can just interact with that on a container platform or VMs across the platform, however they like. You know, they don't have to worry about the software stack because we're providing that now as part of our platform, part of the service that we've built. The hardware is now abstracted away, and we can vMotion it. We can place those VMs or, you know, containerized workloads where it makes sense from a efficiency perspective. And the data scientists can focus on what they're doing, building the models, delivering those machine learning models to production, and IT can wrap those models or wrap those applications in the governance, the control, the high availability that we're used to. And we've done all this with vSphere 7 updates. It's actually update 3 now that we need to move to. That gives us that optimizations on the vSphere side, and then on the NVIDIA side, all the latest NVIDIA GPUs are fully supported by the model. And we also have the ability to carve those GPUs up and make fractional use of those GPUs, or utilize multiple GPUs per virtual machine, depending on workload. So we can carve up that resource to make most efficient use of the GPU or multi-GPUs based on workload. So once again, it's about flexibility of the platform that we can provide to the data scientists. We've got an optimized platform, we're certified on vSphere, and we've got full support from both VMware and NVIDIA. So part of the conversation we have with customers around this platform is how you can best take advantage of the NVIDIA Enterprise solution with your data scientists, what frameworks you should be using, what optimizations could they take advantage of, how you deploy the models on the tool set that's available to you, alongside how you deliver it, obviously, on the vSphere platform with Tanzu, and give that level of resilience. So we can help with things like data prep, which Alastair's already talked to. There's some optimized tools for that with NVIDIA Rapids. How you can do training at scale with TensorFlow and PyTorch, how you can optimize for inference when you're moving into production, and then obviously how you scale that up on the Kubernetes platform. So you get all of that built into the stack, along with access to the registry, which is a set of container images with pre-trained models, common data science frameworks that you can deploy just as Helm charts onto TKG, or you can use there's a collections approach where you can just take those common tasks around data cleansing, data manipulation, and accelerate that. So we're taking the development side of data science and optimizing it as much as we can, so the data scientists get an easier life, so to speak, and they can focus on building the models and understanding the data. They don't have to worry about, is my library the latest? Has it got any CVEs that I should be patching? You know, is it reliable? Can it scale? You know, all of those operational things that honestly aren't normally in a data scientist's first thought, we take care of with the platform. And that's a huge benefit, because a data scientist is always going to use the same library of their TensorFlow framework unless there's a reason for moving forward. And that reason is generally it's faster. They don't really focus on that, I need to patch it because there's a security vulnerability. So that operational side is not part of their traditional mindset. So we're taking that burden away as we operationalize the platform. But equally, not all platforms are built of lots of little pieces. As we move forward with a enterprise grade ML platform for data scientists, moving beyond giving them access to some containers and access to GPUs or access to a VM running Linux and some GPUs, and moving to an MLOps platform. Often customers have built their own, and that's fine, or they're using open source frameworks. But more and more, we're seeing customers wanting to deliver a full MLOps platform that lets data scientists collaborate, share notebooks, share data, share knowledge very, very easily. But they want that platform. They want that stability of vSphere. They want the GPU access. They want the accelerated libraries. So we recognize that not everyone wants to build all the pieces. So we do have a partner that delivers that MLOps piece that sits on top of NVA Enterprise and sits on top of Tanzu to give a full environment for data scientists to work, build their models, develop their code, push that into production on the vSphere platform with accelerated compute from NVIDIA. And that's Domino Data Lab. We work quite closely with those guys. We can go into that in another session, but that delivers an end-to-end ML story across the board. So in closing around enterprise AI and the machine learning piece, it is a team sport. There are AI practitioners that are building these models, analyzing the data, building the AI data that is not visible to traditional IT. And so engaging with those groups and offering to help make their lives easier by being the enterprise IT team that understands some of the machine learning ops, being the Kubernetes platform provider, and delivering that stability, that high availability, the ability to upgrade the platform, give it a secure platform, is really where VMware spends a lot of our conversations. And then that in turn lets us engage with line of business around actually, we've helped take that machine learning model that can it identify a cat or a dog or a broken screen as it comes off a production line, whatever that use case is. We've helped scale it, secure it, deliver it in an optimized way. That's the line of business. Clearly see the value of data science on the platform they have, and then the lines of business can focus on what they're doing, which is feeding back to the development community, feeding back to the data scientists around what they can build next, how they can do it, and they can be assured that we've got security. They've got the ability to get support when they need it because it's from VMware, it's from NVIDIA, and they've got that ability to pick the phone up and ask questions of us, and we can do that quickly and consistently. And that's the key to a successful platform is that having that consistent platform, having that secure platform, having someone to call that understands the pieces. And that's where we've been plugged in with NVIDIA, with data science practitioners to understand and how we can build and deliver that platform. And ultimately, all of this sits on Tanzu Kubernetes grid on the vSphere platform most of the time. Obviously, you get VMs sitting alongside that if you've got really big workloads that you want to just have dedicated processing to, and you can give multiple GPUs to those workloads as well. But the majority of the work we see and the integrations we have is around Kubernetes. Okay. At that point, I'm gonna hand back to Alastair to talk a little bit more around some of the other data services. You still there, Alastair?
Yes, I am. Thanks. Sorry, I was just waiting for you to stop sharing. Great. So if everyone can now see that same picture that Robbie ended on.
Yep, that's coming through.
Great. So the bits down the left of this picture, Robbie talked through a few minutes ago around, we've got some hardware with some cool bits in it. We know how to expose them, manage them, let workloads use them well. And then there are various accelerators in terms of pre-built models, tool sets, and the management suite from folks like Domino to help with that. But right back at the beginning, we were saying, well, data comes into these things. and where does that data come from? So if we go back down to the infrastructure layer here, Robbie talked about the accelerated hardware, the kit for compute intensive workloads with the GPUs for those workloads that work for it. When we need to manage the data, we see another pool of hardware coming in, so to speak, the hyperconverged systems, which are storage intensive, which allow us to hold on to all this data. And while it's not the only kind of storage that matters, I've called out object storage particularly on this picture, because this is really where we tend to find our lake. So that raw data that arrived in whatever form the source system produced it in and needs to be held onto often doesn't need particularly high performance. So from an economics point of view of running these platforms, sort of cheap and deep is generally appropriate for that kind of data, because you'll often only be reading it once. And then that needs to be turned into the data which you are going to use more frequently, that more conformant, the transformed and quality checked data, which will be used for both your traditional reporting environments and your ML and AI world. And there are all sorts of ways of moving those between each other. One of the more practical, less maybe adventurous approaches to this is to treat all of that data in the object store like a table in a database, and to just expose it in the same environment as your data warehouse. So the data lake and the data warehouse don't necessarily have to be separate things, and there are certainly some advantages to keeping them together as a single technology. We see a lot of interesting growth happening at the moment in push down data transformation tools for doing work inside data warehouses, ELT. So Matillion just raised a frightening amount of investment from a number of data warehouse vendors. DBT is one of the big open source players in that area, which seeks to manage queries for running in a big database for doing these transformation jobs, these cleaning jobs. And in that area, VMware has a product called Greenplum. That is part of how I ended up at VMware. I joined EMC to do pre-sales on Greenplum 12 years ago, and Greenplum was one of the products spun out into Pivotal, and Pivotal then got acquired by VMware. So it's been an interesting journey, but Greenplum is our data warehousing software there. Obviously, having moved from hardware company ownership to software company ownership, the options for deploying this have changed. It's now all deployable on the VMs, plays nicely with VCF, vSAN, all of those things. But also, besides the use for the processing, for getting the data ready, the warehouse is usable in and of itself by the analysts. A lot of just getting a feeling for the shape of the data is enabled by having a robust query engine for looking at that data. It doesn't have to be some advanced work in Python or R over text files. That the query languages are quite good for a lot of this. So there's one other journey we spoke right at the start when we were talking about the personas, about the journey of the data, about the journey of the model. The journey of the scoring decision is the fourth piece of this, and this it it crosses into the application team space from the MLOps space, but it's still a little uncomfortable sometimes in terms of where that should live. So the first thing is managing and scaling the request traffic. So these models that are managed and deployed by a tool like Domino will receive requests from applications in the field, from other internal systems, and they will need to process however many of them they can. These are generally stateless things. You can scale them out horizontally, and having a classic microservices application deployment pattern for them with something that can distribute the workload like a queue and a bunch of optimistic consumers, the hungry consumer or competing consumer pattern, is a very good way, and one that I think we can learn from the software development in the application world for the AI and ML world. The other thing that needs to happen during this process, potentially between the request arriving and it being handed out to one of those model serving instances, is that we may need to add more features to the data that came in. So if you recall at the beginning, we were talking about the journey of data. We talked about how once the data is reliable, conformant, all the rest of that, it sometimes still needs to change shape in order to be useful for machine learning. So the flip side of that, when we start serving the models, is that we want, maybe not all, but we want a lot of that same data to go back into the scoring process. And in a simple example around this, if we're talking about a credit card transaction, the thing that comes in the first place will be the merchant number, card number, and an amount. That's kind of where we start. And then the additional values that need to be added to effectively assess the fraud risk of that transaction include a few things about me as the card holder. They may include a few things about the merchant, some spatial data, for instance. But they could also include a whole number of other things which are used to determine the risk. And this is the other side of the feature store, the filling out data to be able to more effectively use it in a scoring or a decision situation. A very interesting example here is MasterCard's decision management platform. They spoke about it at our Spring One conference a few years ago. So they have an in-memory data grid with somewhere around 6 billion integers in it. Those totals are running totals for geographical regions, issuing banks, merchants, the merchants' banks, et cetera, et cetera. Every time a transaction is assessed, it updates 60 of these running totals. So when you're pushing through 1 billion transactions a day, and when the features that are relevant for assessing whether a transaction is a risk or not need to be up to date in order to spot any distributed attacks, the feature store can become quite a big piece of infrastructure, big enough to stand up and talk at a conference about. So that is just the other interesting role, the other interesting technical role that happens during this process. We've talked about the technologies involved in acquiring the data, in letting the analysts do their thing, taking those results and putting them into production. But on the request side, we again see another whole family of technologies. So then, just to summarize where the the VMware Data Solutions side sits and works in this whole picture. RabbitMQ is our message broker. So that model I was talking about around the competing consumers moving a set of requests out to be processed by an elastic pool of workers, because once you're putting these things out as containers in a Kubernetes environment, you can scale them reasonably easily. And then all the other related roles in application architecture, microservices application architecture. For the in-memory data, Gemfire. So this is what MasterCard built that solution on that they were talking about for their ridiculously large feature store. Feature stores shouldn't generally end up that big. The relational databases, every app needs one, right? So we are also a vendor of packaged supported Postgres and MySQL, and in keeping with VMware's general role in managing workloads, deploying them sanely, etc. Our key value add there is a database as a service wrapper around Postgres and MySQL to make it easier to roll them out for app teams, for your data science teams, etc. And then, as I mentioned, sort of 2 slides back, when there's just too much data to fit into a single small database, Greenplum is our scale-out analytics DB. One of our former heads of R&D used to jokingly refer to it as Postgres for petabytes. So a large number of database instances all working together to parallelize a workload for those kinds of work which are appropriate for that. So big scans, big aggregates, some of the in database machine learning primitives, and then present it all back so it looks like just a very fast database engine to either the analyst or any of the applications using it. So now you're all in on VMware's best kept secret, that we are also a data company. Great. Thank you very much for everyone's time. Do you then have any closing words, Robbie?
No, thank you for your time, everyone. I don't know if there are any questions at all. I mean, is there anything come up in the chat?
Nothing that's come through yet. I'm just going to give it a few seconds just to see if any of the participants want to post any questions, and then we can close up for today's webinar. Okay, nothing's come through, so I think we are good to close today's webinar. Alastair and Robbie, thank you so much for taking us through VMware Data Solutions. It's been really great to hear how we can support our customers on their data journey. As we mentioned at the beginning of the webinar, this presentation has been recorded and your TAM will be able to make that available to you. Please do join us next month on December 8th when we'll be taking a look at vSphere 8. Thank you, everyone.
Great. Thanks, everyone. Bye.
Thank you.